Let's look at something called trig identities. So this one here is a very popular identity. Sine squared plus cosine squared is equals to 1. But where does that come from? Let's say we have a quadrant, and in that quadrant we have some angle theta. This is the opposite side, this is the hypotenuse, this is the adjacent side relative to that angle. What is the formula for sine in terms of OH and A?
O over H.
What about for cosine?
A over H.
A over H, right? Now you see this sine squared theta, this thing, sine squared theta. What this means is you take your sine theta and you square this entire thing. That's what it means. You're squaring the entire ratio. So if we follow this formula here, sine squared theta, you take this entire thing, whatever sine theta is, and then you square it. So you do O over H squared. Similarly, cosine squared theta means you take your A over H and then you square it. And then I guess you can open the brackets. You get O squared over H squared plus A squared over H squared. They have the same denominator, so you can combine the numerators like this. Now look at that triangle. What's O squared plus A squared?
It's H squared.
Right. And then you get H squared over H squared, and that is 1. So that's where it comes from. So this right here is a very important identity. Sine squared plus cosine squared equals 1. There are two main identities. One of them is that one. The other one is tan. What's the formula for tan? It's something over something.
Opposite over adjacent.
That's right, opposite over adjacent, but there's another one. It's in terms of sine and cosine, because you may not be always given a triangle. Tan is sine over cosine. Here we can prove it. So we know tan is the opposite over adjacent, but where did this come from? If you follow that formula, right? Sine theta is opposite over the hypotenuse. Cosine theta is adjacent over the hypotenuse. And the h's cancel out. That's how you get O over A. But originally, this comes from the fact that tan is sine over cosine, okay? So we're going to use that identity. So it's going to be sine over cosine. These are the two main identities that we're concerned with right now. Let's look at this one. What is the formula for cotangent? It's a negative, sorry, not a negative, it's a reciprocal of something. What's cotangent a reciprocal of? Sine, cosine, or tan? It is, so these are called the secondary ratios. It is of tan, okay? It is of tan. So keep that in mind. So we know tan is sine over cosine. Now, if cotangent is the reciprocal of that, what's the formula for cotangent in terms of sine and cosine? It's flipped upside down. That's going to be cos over sine. Okay? Tan is sine over cosine. Cotangent, it's the reciprocal of tan. It's going to be cosine over sine. So now we can plug that in here and see where that gets us. So 1 over cot squared theta just means it's cot theta whole squared. And we know cot is cosine theta over sine theta. Let's open the brackets. So you get 1 plus cosine squared theta over sine squared theta. What's the common denominator?
Sine squared.
Yeah, so I'm going to multiply that 1 by sine squared theta on the top and on the bottom. Then you get cos squared theta here on the top and sine squared theta on the bottom. Now that they have the same denominators, we can combine the numerator. What's sine squared theta plus cos squared theta? We have the identity right up there. See these?
It's 1.
It's 1, right? And then you get 1 over sine squared theta. What's 1 over sine squared? What's the reciprocal of sine? So you have cot, sec, and cosecant. All of these are reciprocals. The reciprocal of sine is cosecant or CSC, okay?
Mm-hmm.
If you have 1 over sine, it's going to be cosecant theta. If you have 1 over sine squared, it's going to be cosecant squared theta, like that, and you're done. So the idea is you start on one side, and then somehow using some algebra, you get to the other side. And if you are able to do that, it's called a trig identity, okay?
Mm-hmm.
So keep that in mind. Cosecant is 1 over sine. Cotangent is 1 over tan. And secant is 1 over cos. Cotangent is also cosine over sine because tan is sine over cosine. So there's more to it. And what is this letter called? 10 points. Is it an O?
No.
Is it an OI, OL, something like that? It's called phi, PHI. I don't know all the Greek letters, but alpha, beta, theta, gamma, whatever, it's not important. It's just another way to denote X. Okay, usually you use Greek letters because you don't want to confuse the English letters with the English lettered functions. That's why you use Greek letters. But you can literally replace this with A or X and it's not going to make any difference. So here they are asking us to prove this. What you want to do is you always want to start, okay? Always start on the side that's more difficult. That looks more difficult. Cool?
Mm-hmm.
So would we start on the left side or on the right side here? Which side looks more difficult? Which side can we do algebra on? It definitely has to be the right side because on the left side you just have a tan. You can't really do much with it. You could write sine over cosine on the left, but that's not gonna do much. We're gonna start on this side. There's multiple things you can do, but there's always one best thing you can do. Look at the numerator. Can we pull anything out? Do they have anything in common in the numerator?
Sine.
Yeah, you can pull out a sine, right? Let's see if we can do that. So I'll pull out a sine. What am I left with? On the numerator, if you pull out a sine, what are you left with? It's the same idea as this. If a plus a squared, you pull out an a, you're left with 1 plus a. Here we have
So 1
sine,
plus sign.
1 plus sine, that's it. Can we cancel these two out? This bracket and this bracket?
Yes.
Yes, you can. What if there was a plus sign here in the middle? Could we cancel them out?
No.
No. Right now we can cancel them out. So this and this is gone. What's sine over cos? Sine over cosine is a tan, and you're done. That's it. It's just a two-step thing. Cool?
Mm-hmm.
Just remember that. Tan is sine over cosine. Know your reciprocals and know sine squared plus cosine squared is 1. And you can pretty much do everything. This one is a little bit tricky, I think. Which side should we start on? It you should probably start on the left because you can do more things with that compared to 1 plus sine. So let's say you have sine squared plus cosine squared equals 1, okay? What if
Mm-hmm.
I want to isolate for cosine squared? What is that equal to? It basically means you want to move the sine to the other side.
It's 1 minus sign.
Yeah, it'll be 1 minus sine squared. So let's try that here. We're going to start on the left side. I'm going to replace cosine squared with 1 minus sine. Let's see if that gets us anywhere. Cool. So see, it'll get us somewhere. What form is this in? It's in a certain form. It's in the form of,
Difference of squares.
yeah, exactly. So if you use the difference of squares on the numerator, what do you get? It's going to become something plus something times something minus something.
1 plus sign and then 1 minus sign.
That's it. Can we cancel out the 1 minus signs, these two?
Yes.
Yes, we can, and there we go. We get the other side, right side. So we proved this. Okay, that's the entire goal. All you had to know here was this. And sometimes you do have to play around with it. All of these are pretty, I think, 1 or 2 steps. Which side would you start here, left side or right side? Which side can you work on?
The left side.
The left side. What is the formula for tan?
Sine over cosine.
Right, sine over cosine. Now you have 3 levels here. Does the cosine go all the way to the top, or does it go on level 2? So you're kind of like in this form, a over b over c, which is the same thing as a divided by b over c. Now if you change that into a multiplication, it becomes a times c over b. So using this idea, the cosine that's on the very bottom, is it going to go to the top or is it going to go to the denominator?
The top.
The top. So you get sine x times cosine x divided by sine x. Can you cancel the signs?
You can?
Yeah, and there we go, we're done. It doesn't matter which side you start on, honestly. They're both gonna be 2 steps. The formula for tan is sine over cosine. Then you have a cosine on the bottom. Now again, a question for you. Does this go here or is it gonna go all the way to the top? Level 1 or level 2?
It's gonna go to the top.
Okay, let's check. So this is the same thing as a over b divided by c. Okay, slightly different from last time. Last time we had a divided by b over c. That's why c went to the top. But here you'll see that c is gonna go in the denominator. Okay,
Mm-hmm.
notice the difference between them. One of them has, this one has a fraction in the numerator. The last one that we did had a fraction in the denominator, so it's gonna depend on where the fraction is. This one, it's gonna go in the denominator, not in the numerator. So this becomes sine theta over cosine theta times cosine theta. And we know cosine theta times cosine theta is cosine squared theta. And we did this earlier using this guy. Sine squared theta plus cosine squared theta equals 1. What is cosine squared theta? It'll be 1 minus sine. You just want to move this to the other side, right? A plus b is 1. That means b is 1 minus a. Same idea here. Sine squared plus cosine squared is 1. That means cosine squared is going to be 1 minus sine squared. And you're pretty much done, because that's what we have on the other side. That makes sense?
Mm-hmm.
So this is just pure algebra. Calculator is not going to help you here. This one is slightly trickier. I guess you don't want to start on the right side because you can't do anything with anything there. But on the left side, you can definitely change that tan into a sine over a cos. Let's try that, because that's the only thing that we can do. And actually, you're done. It's super simple, because you have the same denominators. You combine them, and on the numerator, you get 1 plus sine alpha. Super easy, 2 steps. That makes sense?
Mm-hmm.
Always start on the side you can do something on. Like here, for D, I would start on the right. Because I know I can change that tan into sine over cosine. Let's try that. Sine theta times cosine theta times sine theta over cosine theta. Cosine theta and cosine theta cancel out. You get sine squared theta. Again, going back to this, sine squared plus cosine squared is 1. What is sine squared theta?
1 minus sine squared.
1 minus cosine squared. Sine squared is 1 minus cosine squared, and that's what we have on the left. So you start on one side and then you end up on the other side. That's all you have to do. It's just that easy. But what about some complicated ones? Okay, yeah. Again, this is just pure algebra. The identities we need to use is tan is sine over cosine, and sine squared plus cosine squared is 1. Which side would you start on? And the answer is it doesn't really matter, because you can do something on both sides of this thing. But I'm gonna start on the left, because that tan, I know I can change it into a sine or a cos. Let's try that. Minus cos squared alpha, this is alpha, the letter A, minus sine squared over cosine squared. What's the only thing we can do for the next step? There's only one thing we can do. What is it? You take the common denominator. That's the only thing you can do. There's nothing much. So if you take the common denominator, what is it in this case?
Cosine squared.
Cosine squared. So let's turn sine squared alpha minus, well, this is going to become cosine. What's cosine squared times cosine squared?
Cosine to the power of 4.
Yeah. Minus sine squared theta. The first term would become sine squared cosine squared. Yeah. Becomes sine squared cosine squared all over cosine squared thing. This guy. And this next part is complicated because I'm looking at the other side. They only have sines, so we need to somehow get rid of the cosines. Sine squared plus cosine squared is 1. What is cosine squared equals to?
1 minus sine squared.
1 minus sine squared. So I'm going to replace this cosine squared with 1 minus sine squared. Why am I doing this? Because on the right side, I don't see any cosines. So we know we need to change our cosines into sines. So sine squared times 1 minus sine squared. So replace that cosine squared with 1 minus sine squared minus. And we know this cosine squared in the denominator is also the exact same thing. We can replace that with 1 minus sine squared alpha as well. What about cosine 4 theta? What do you think that is equals to? If cosine squared is 1 minus sine squared, what's cosine to the power of 4?
1 minus sine to the power of 4.
Go try. It's going to be 1 minus sine squared alpha. Okay, the exact same thing, whole squared. If a squared is 2, a to the power of 4 is a squared squared, right? So it'll be 2
Mm-hmm.
squared. You need to square that entire thing. So cosine to the power of 4 will be 1 minus sine squared alpha to the power of 2. That entire thing squared. And then you have minus sine squared alpha, like that. Let's open the brackets and hopefully we get something. So if I open that first bracket, what do we get if you open this bracket? Let's open it.
Sine squared minus sine to the power of 4.
Right. The next bracket is slightly difficult. For the next bracket, you want to do, you can always use the formula for a minus b whole squared, but you want to multiply it like this. When you do this, you get 1 minus 2 sine squared alpha plus sine to the power of 4 alpha. So we're going to replace that with this, and there's a negative sign on the outside, which means all of these are going to be, their signs are going to be flipped. So it'll be 1 plus 2 sine squared alpha minus sine to the power of 4 alpha. And then finally you have minus sine squared alpha, this guy here at the end, all over 1 minus sine squared alpha. And I think we're almost there. So positive sine squared and negative sine squared cancels out. And And now if you just rewrite this, we will get what we have on the other side. So I'm gonna write this term first, because that's what they have up here. And then you can combine negative sine 4 into 2 sine 4. And then you have a -1 there at the end. So we're done. So it's going to be like this. And that's the end. Okay.
Mm-hmm.
So this one was definitely more difficult because of this thing. If you see power 4, you need to do something whole squared. If you see power 6, you need to probably do something cubed. That's what makes it a little bit more difficult. This next one is also difficult. Where do you want to start? Always start on a side you can do more things on. Where do you start? Probably on the left. Let's start on the left. What's the formula for sine squared? Again, it comes from the sine squared plus cosine squared is equals to 1. So what's the formula for sine squared?
1 minus cosine
Yeah,
squared.
1 minus cosine squared. So you have plus 2 cosine theta minus 1. Same thing on the denominator. You have 1 minus cosine squared theta plus 3 cos theta minus 3. On the top, this one and this one cancels out. So you're just simply left with okay, we'll hold on for that. You can take out a cosine theta, but I'm gonna save that from the next step. Now in the bottom, you have 1 minus 3 becomes -2. Minus 3 is -2, so like this. And this one, again, you have to be able to identify. This is in a certain form. I'll give you a hint. It looks something like this. What form is that? It's a quadratic trinomial. What do we do with quadratic trinomials?
Remand.
You manage, right? So what you can do is you can take out that negative sign, make life a little bit easier, I think. Take out that negative sign. So we're looking for two numbers that multiplies to 2 and adds to -3. Multiplies to 2 and adds to -3. What are the numbers?
-1 and -2.
Yeah, -1 and -2. So you can rewrite that as a minus 1 times a minus 2. A is just cosine theta. That's the only difference here. This entire thing is a, okay?
Mm-hmm.
So then you get minus cos theta minus 1 and cos theta minus 2. In the top, I'm going to take out a negative cosine. I'll be left with cos theta minus 2 as well. So this is what we have right now. Does anything cancel out? Can we cancel
No.
anything? So this bracket and this bracket would cancel out. Look at it. They're the same brackets and you're multiplying them. So this one and this one's gone. And also the negative signs are gone. Which gives us cosine theta over cos theta minus 1. Now this is an advanced technique. On the right side, we have cosine squared theta plus cos theta on the numerator. Right now, we only have cos theta in the numerator. You need to multiply this with something to get this. What do you multiply that by? You need that as your final result. You only have cos theta right now. But if you're to multiply it by a certain thing, certain term, you would get that. What's that term?
Cosine theta?
Cosine theta is one of them, yeah. Cosine theta, just cosine theta?
No.
Plus what? So you got your cos squared.
Plus 1?
Plus 1 is right, yep. So this is the advanced technique. You need to multiply this by that to get the desired numerator. But when you can't just randomly multiply something with whatever you want. But if you do it on the numerator and the denominator, then that's allowed because you're basically multiplying it by a 1 because this and this cancels out. Okay? So this is probably the
Mm-hmm.
trickiest technique. You can always multiply it by something as long as you do it on the top and on the bottom because essentially you're just multiplying by a 1. And we'll get the answer right now. So this will be cosine squared plus cos theta on the numerator. And on the bottom, we have a difference of squares, so it'll be cos squared theta minus 1. Again, let's go back to here. We want cos squared theta minus 1. That means we need to move this to this side. And we need to move the sign to the other side. So if you look at this, cos squared theta minus 1 is what? Just moving this to the other side becomes negative, like that. So cos squared theta minus 1 is simply negative sine squared theta, and that's going to be the final answer. So here a lot of techniques were used. We had to use man, and we had to multiply and divide by the same term to get the desired result. So this one is pretty advanced, but eventually you'll be able to see it. Once you see it, it's not that difficult. It's just something new. Does this make sense?
Mm-hmm.
Do you want to start on the left side or on the right side?
The left side.
Yeah, there's no point starting on the right side. There's nothing you can do. So let's start on the left side. And again, the only thing we can do is change that tan into sine squared or cosine squared. Now think about this long and hard. This cosine squared, is it going to go to the numerator or is it going to go to the denominator?
The numerator.
Yeah, it's going to go to the numerator. So you're going to have sine squared times 1 plus cosine squared x divided by sine squared x. There's only one thing we can do. What is it? By the next step, there's only one thing.
Common denominator.
Common denominator. That's the only thing we can do here. So you're going to get sine squared x plus cos squared x divided by sine squared x. What's sine squared x plus cos squared x? This is,
It's 1.
that's 1, right? So this entire thing is 1, and then sine squared x and sine squared x cancels out. So you're essentially it's 1 over 1 of 1. And that's what they have on the right side, and you are done. What's cosecant squared a reciprocal of? Sine or cosine?
Sine.
That's right. So the only thing you can do here is you do 1 over sine squared. Secant is 1 over cos squared. The only thing you can do in the next step is you take the common denominator. What's cos squared theta plus sine squared theta? 1, right? And then you have 1 over sine squared. You can do it either way, actually. I'm going to show you both ways. You can do it like that. So this right here is going to be cosecant squared, okay?
Mm-hmm.
You can always multiply by a 1, keep that in mind. What's 1 over cosine squared? It's secant.
It's sine squared.
Secant squared. 1 over cosine is secant, 1 over sine is cosecant. So this comes with this, and this comes with this because I just multiplied it by a 1.
Mm-hmm.
Now, does that look like this is a 1? No, right? This is not a 1. There's nothing we can do with this. So no, this is not correct. It is not equals to 1. Okay?
Mm-hmm.
That's how you can show something as true or false. You'll see that it's, once you get a hold of some of the ideas, it's not that difficult. Here, let me just run you by what I think is going to happen. Here, if you change sine squared into 1 minus cosine squared and use a difference of squares, this will cancel out with 1 minus cos squared on the numerator. You're going to get that answer in 1 step or 2 steps. For B, the only thing you can do is change the tan into sine over cos, and things are going to cancel out, and you're going to get sine squared. This is the only thing you can do on the numerator. On the denominator, this is the only thing you can do. Look at the denominator. What do we do between for 1 and cos squared? There's only one thing you can do between them. And that is to take a common denominator, right? Of cos squared. You have something like this. Can we cancel out this cos squared with the cos squared on the very bottom?
No.
All right, let's check. So you have a over b divided by c over d. Or actually, it needs to have the same thing. So let's say it's also c over b. This is the same thing as a over b divided by c over b. Let's flip this. So you get a over b times b over c. You see these two cancels out. These two cancel out. That means cos squared and cos squared here, you can cancel them out. What is cos squared plus sine squared now? That's the only thing that's left. What is this equal to?
1.
1. And there you go. You have sine squared over a 1. It's just sine squared. And you're done. Because that's what you have on the right side. This one is just straight up a difference of squares. If you use a difference of squares formula on the right, what do you get? You have 1 minus something and 1 plus something. If you combine them, what do you get? It'll,
Sine x squared.
it'll be 1 minus sine squared x, and we know that is cosine. Like we've done this a few times. Equals 1. So 1 minus sine squared means you throw this to the other side. You get cosine squared x is 1 minus sine squared x. So you can replace this with cosine squared x. And it's proven. Just a few steps. Not that difficult. This one you have to recognize. Well, first of all, there is no sign on the right side. So you need to get rid of that sign. What's the formula for sine squared? Sine squared only has one formula.
1 minus cosine squared.
Yeah. So it'll be 1 minus cosine squared theta plus 2 cosine squared theta minus 1. This and this cancels out, right? 1 minus 1 is a 0. What's negative cosine squared plus 2 cosine squared? What does that equal to?
Cosine squared.
Cosine squared, and you're done. Easy peasy. This one looks difficult, but it's not. You have to see it, that it's in a certain form. If you use a difference of squares on the left-hand side, what do you get? So it's in the form of a to the power of 4 minus b to the power of 4. It'll be a
Sine
squared.
squared minus cosine squared.
Yeah, sine squared minus cosine squared. What are the other bracket?
You just do plus.
You just do plus. And you basically have the answer because sine squared plus cosine squared is a 1. Multiplying by 1 makes no difference. So it's just a one-step answer. F, again, you start on the left side. There's only one thing you could possibly do, and that is change that tan into sine over cosine. And does this cosine go here or all the way up there?
All the way up.
Yeah. So you have sine theta over cos theta plus cos theta over sine theta. Take the common denominator, you get sine squared theta plus cos squared theta all over cos theta sine theta. What's sine squared plus cos squared?
1.
1, and you're done. On cos theta sine theta, you can rewrite that as sine theta cos theta. And that's what you have on the other side. So this identity has been proven. Is this making sense?
Mm-hmm.
It's not that difficult. Not doing the bearing question. We've done this before, sine law, cosine law. It's pretty simple. So SOHCAHTOA is exclusively for right angle triangles. But if the angle is not right angled, then you have to use either the sine law, which is this guy here. There's two variations of it. Depends on whether you're looking for the side length. You're going to use this if the side length is missing. You're going to use this if the angle is missing. That's the sine law. What is 1a asking? It's asking us for theta, right? So the angle is missing. You want to use this formula here. So how does this work? Look at this. You only use 2 at a time, by the way. There's like 3 of them being equals to each other, but you only use 2 at a time, either AB or AC or BC. You never have to use all 3 of them at the same time. So since the angle is missing, I'm going to follow this formula for A. And let's see what that gets us. So theta is missing. So I'm going to say sine theta divided by, now this A is simply the side that it's opposite to, okay? What's the side length opposite to theta?
15.5.
Then you put 15.5 on the denominator. That is going to be equals to and you take another angle and another side length. So another angle is 105, and the side length is 20.5, like that. How do you solve this equation for theta? Theta is missing. It's a linear equation. The difference being you need to do sine inverse.
You multiply by 15.5.
That's correct. You multiply by 15.5. So you have sine 105. Make sure I'm in degrees. Sine 105 divided by 20.5 times 15.5, and then you just do sine inverse, and you have it. So that's going to be 46, or let's say 47 degrees to the nearest whole number, and you're done. Help me set up for B. It's gonna be something over something equals something over something. Again, the angle is missing. This is the formula to use. I'll give you one of the numerators. It's gonna be sine theta. Sine theta over what? It's always going to be the side that it's opposite to. What is opposite to theta? 9.
15.5.
No, so we're done with that. We're done with that. I'm looking at B. What's opposite to theta?
9.
9, that's it. And then is equals to something over something. What do you think? I'm using this formula here. So the only other angle we have is 38, so it's going to be sine 38 divided by what?
7.
7, that's it. And then you multiply both sides by 9 and then do sine inverse and you'll get the answer. So it'll be sine 38 times 9 divided by 7. Sine inverse of that is 52 degrees. And you are done. Cool?
Mm-hmm.
And then this is where it's going to be super powerful. So there is a tree that's leaning and it makes an angle of 12 degrees with the vertical. Okay, let's say this is the vertical line. And let's say this is the ground. And let's say this is the tree. It's leaning and it's making an angle of 12 degrees with the vertical. So that angle there is 12. To prevent the tree from falling, a 35-meter rope is attached to the top of the tree and is pegged into level ground some distance away. Okay, so let's say the tree's falling down this way. I'm gonna attach something to this, right? Would it make sense to put it here, or would it make sense to put it on this side? Which one of them will prevent it from falling over, A or B? Or both? I think B would make more sense.
Mm-hmm.
Because A would be pulling the tree towards the ground, whereas B you'll be pulling it away from the ground. Let's stick with B, but technically the answer is both, okay? You can definitely make some setup that will stop it toppling over from A, but let's go with this one. This one's making more sense. So this rope is 35 meter. If the tree is 20 meters from its base to its top, so what is 20? Which side length is 20?
8. to C.
A to C is 20, definitely. Calculate the angle that the rope makes with the ground to the nearest degree. So which angle are we looking for?
B.
B is right, yes. So we're looking for this angle. Let's call that theta. Now think about it. This is the vertical, okay? It's the vertical line. This angle is 12. What is going to be this big angle? Or we don't know. You have two options. Either you give me a number or there may not be a way to find that.
Is it 102?
It is 102 exactly. So this big angle is going to be 102. And we need this big angle because this 35 meter, the opposite side length comes from this big angle, not from the 12. So now it's pretty simple here. Look at the setup. It's going to be sine of theta, okay? What is the opposite side length of theta?
20.
20 is equals to sine of something over something. What? Use the other two numbers that we haven't used.
Sine of 105 over 35.
That's correct. Very simple from here. You multiply both sides by 20, and then you do sine inverse, and you'll get the answer. So let me plug that in, times sine of 105, and then sine inverse of that gives me an angle of 33.5. That made sense? Okay, for a moment, let's consider the other possibility that our rope is on this side. And the length of the rope is 35, and this is the angle that's missing. So basically your setup will look something like this. This is 12 degrees, and then you have this. We know this is 20 meter, we know this is 35 meter, and we know this is the angle that's missing. What would be this angle? Basically, which is this angle here. Do we know?
78.
78. Now let's plug these numbers and see what changes. So it's going to be sine of theta, okay? The opposite side to theta is still 20. And that is going to be equals to sine of 78 divided by what? 78 is here. The opposite side is 35, so it's going to be
35.
35. Now let's find sine, theta, sorry. So it'll be sine 78 times 20 divided by 35, sine inverse of that, and that gives me 34 degrees. So a slight difference here. This one was like 33.5, this one was like 34, so a slight difference. The point here is that that difference is significant. You can definitely make an argument for where you would want to place the rope. Both of these would work, okay? The fact that we got slightly different numbers here has to do with something. It's called the ambiguous case of the sine law. I can show it to you in more detail next time, but basically, there's always going to be two triangles that you can draw. There's always going to be two answers to things. That only happens for sine law, and it needs to meet certain conditions. I can talk about the conditions later, but does this make sense? Why you can have multiple angles?
Mm-hmm.
Because you can either put the rope here away from the tree, or you can put it here towards the tree. I mean, they're both feasible. And depending on where you put them, you're gonna get different angles. All right, let's call it a day there for today.
Okay, thank you.
See ya.